Hi, I'm Amanda Jones, and in this video I'm going to show you some ancient numeration systems. So our system is the Hindu-Arabic system using digits 0, 1 through 9, and it's a base 10 place value system. But before it came along, there's been all these different systems that kind of were in existence before ours. We're going to look at the Egyptian, Mayan, Roman, Babylonian, and Greek in this video. And one of those might be familiar to you, and that's the Roman system. You guys all know Roman numerals that we still use to make pretty numbers here and there on like clocks, or we use it for our Super Bowls. And so that's one that's still around and still in use quite a bit today, but most of the other ones have kind of been replaced by our numeration system. Now, numeration systems can be either additive or they can be place value. Ours is place value. It's a base 10 place value system, which means that in that string of digits that make up a numeral, it matters where the digits are placed as to what their value is. So you have the ones, the tens, the hundreds based on where that digit is in the numeral. And then an additive system, it doesn't really matter. Usually we have a pattern of how we write those and what order we write them in, but we just take the values of the symbol and add them together. And so we'll start with an additive system, which is the Egyptian system. Now I'll put a link to where you can find the symbols for each of these and what they mean in the description down below this video, so you can look into that and explore what each of the symbols means. There's more than what I will show you in this short video. So starting with Egyptian, like I said, it is an additive system, which is a little different than what we're used to, but we kind of you might like it. Roman system is also additive. So I'm going to kind of draw. I'm not the greatest artist, so I'm going to draw these kind of hieroglyphic symbols that represent numerals, and then we'll talk about what each of them mean and what the quantity that it represents is. Okay, so Egyptian numerals, they can write them in this order. You can also see it reversed, so where these values are down here and these are at the top. So you'll see it both ways with the Egyptian system. Each symbol represents a number. Egyptians were pretty smart, so they did use powers of 10 for their numbers. And I didn't skip any numeral, so each place value, there's no 0 in this number is what I'm trying to say. So these are ones, these are tens, these are hundreds, and these are thousands. So this is called a lotus flower, and it represents the thousands. So there's 2 lotus flowers, so you have 2,000. This is a coiled rope, and there are 4 of them. They represent 100, and so since there's 4, then we have 400. I'll write it in expanded form. Okay, this is a horseshoe. Okay, there's 8 of them, and they are representing 10. So one horseshoe equals 10. 8 of them is 80. Okay, and then we just have our kind of tick marks, which I think they call sticks, and there's 3 of them. So there's our Egyptian numeral, 2,483. So not too bad. It's a pretty easy system, just remembering or looking up what each picture represents and adding them up. So it's an additive system, which is why I could write this in reverse and it would still represent the 2,483. Okay, let's move on to the Mayan system. Mayan is a place value system, and it's kind of a modified base 20 system. They say that it's because Mayans walked around bare feet, so they used their fingers and their toes and had kind of a base 20 system. And we use a base 10 system, 10 fingers, 10 toes, so we kind of separated it out a little bit more. But they got to 20 squared, which is 400, and said, I don't want it to be 400. There's 360 days in the Mayan calendar, so I want my third place value to not be 400. I want it to be 360. So that's why it's modified a little bit. So their place values for the Mayan system, that's place value system, okay, it's modified base 20, right? Meaning that we have our 20 to the 0 power, which is 1, that's the first place value in their system. 20 to the first power, which is 20, that's the second place value in their system. They write these vertical too, I'll show you that. It's a little different. And then they get to 20 squared, and they don't like that. They want it to be 360. They want this value to be 360. So what they did is chose to use 18 times 20 to the first power, which is 360. And they kind of kept up with that. So they took 360 and multiplied it by 20 to get the next place value. So you can see that as 18 times 20 squared, which gets us to the 7,200. And then their next one is 18 times 20 cubed, which gets us to 144,000. So these are the place values for the Mayans, and they do write these vertically, and they write them from bottom up. And so the bottommost layer is the ones, and then the secondmost layer is the 20s and so on. And they don't use digits, they use symbols. They use a line to represent 5 in that place value, and they represent a dot to represent 1. And they started out, I think they started out without having a placeholder, a place for 0. So like if there were no 20s in the number, how do you show that there's nothing in that place value? And they decided to use a bowl. They call it an empty bowl. Me and my artistry skills here again. It looks something like this to represent their placeholder, or 0, meaning that there's nothing in that place value. Okay, so keeping this in mind, let's look at a Mayan numeral and convert it to our system. Base 10 with our digits that we know and love. All right, so if we were to write 2 lines, 4 dots, have our shell or bowl. Some people say it's a shell, some people say that it's an empty bowl, and 2 dots here. They always write the lines at the bottom of their place, in their place values. Like all this is in the same place value because I've got these pretty tight together, and the lines are at the bottom. It can get a little confusing. Like if I wanted to write 6, you want to make sure to do this, okay, where it's real close, and not this, okay, because this would be 5 plus 20, because this would kind of look like it's in the next place value. So if it's in the same place value, we try to keep them real tight and use a big space when it's moving into the next place value, which is what makes it hard to use, symbols instead of digits sometimes. You can kind of see why we love our system. So this would be 25, this would be 6. So be careful with that, and just know that if you're going to see me write it or a textbook write it, that they try to make it really clear in a big space when it is moving into a new place value. Okay. All right, so let's figure out this numeral. We've got 2 lines, so this is 10. This is in our ones place, so this is our first place value. This is our second, and this is our third. Okay, we know that this is always alone. It's a placeholder, so it's always alone in its place value. And so that kind of helps us separate in this particular numeral here. All right, so we've got this in our first place. This is our ones, so 5, 10 plus 4, so 14 in our ones place. nothing in our 20s place, and then 2 360s. So remember, it's not 20 squared, it's 18 times 20 because they wanted it to be 360 to match the number of days in their calendar. Okay, they liked that number better. All right, so 2 times 360 is 720 plus 14, we get 734. All right, let's try it the other way. Let's look at a base 10 number and represent it in Mayan. All right, let's try 126. Okay. So think about your powers of 20 and or what the powers that the Mayans use, the place values the Mayans use, the modified powers of 20. So 1s, 20s, 360s. And think about the biggest power of 20 that will fit into this, and it is 20. And so I like to do this with division. I think that moving into place values other than like a binary, it's helpful to kind of see the division. So think about, you know, what your place value is, and how many 20s do we need? So we know it's 20, 360 is too big, but how many 20s? Because it's not like a binary where you can only use one or none. We have to kind of move into thinking about how many 20s there could be, and there could be as many as 19 20s in a place value before we move into the next place value. Okay, and so I'm going to divide this by 20 to just show you this. I think you know what it would be. How many 20s are going to fit? Let's show this division. So 20 into 126, of course it'll go 6 times. 20 times 6 is 120. And we do the subtraction and we have 6 left. So this shows you that you have 6 20s and 6 left over. And this is how many 1s you have. So we have 6 20s and 6 1s. So we would write in our 20s place 6, and then we would write in our 1s place another 6. So this would be 6 times 1, or 20 to the 0 power, which is 1, plus 6 times 20. Let's do one more. Okay, let's do 685. Now 360 will go into this, and so we know we're going to go all the way at least into the 360s place. The next place value for the Mayan is the 7,200, and so we know that's too big for this. So we know that the biggest thing that will go into this is the 360. How many 360s? Let's do the division. Okay, once again, I like to just do this to show all the steps so you can apply it to any number. Now it just goes one time. You can do the subtraction. All right, so 1 360. Now we go down to the next place value, and it's 20. And we do know that 20 will go into 325. So this is what's left over. When we have a remainder, this is what's left over to represent. We know we're going to have a 1, a dot, in the 360 spot. I'm going to go ahead and put that over here. So this will be the 1 in the 360s, representing 1 times 360. Okay. But I still have to take care of 325. That's what's left after putting 360 into 685. So I'm going to see how many times 20 will go into 325. Once again, it can be as big as 19. So 20 goes into 32 one time, because at 20 it would go up to the next place value. We've done something wrong. Okay, we're at 125, and it goes in 6 times. So this is how many 360s. This is how many 20s. So I'm going to go ahead and write that, 16. So 5, 10, 16. Remember, it goes up, I guess, with the ones and then the 20s and then the 360s. So this is representing the 16 times 20. Okay. And then our units right here. So this is how many times 1 we go, like how many we have left. We have 5 units. So we'll do another line. And I need to make sure that's big space. You know that this is going to be in the ones place and this is starting our 20 space because of that big space. But we would use a shell if we had an empty place value. So we do know that this is ones, 20s, 360s. Okay. So let's move to a different system. We'll move to the Roman. Now, the Roman is quite common and you can find a lot about it. It is additive, which some people might not realize, but it is additive. We take what each symbol represents and add them together. Now there is kind of a rhyme and reason and rules behind, what order we put them in. The Roman is pretty cool because it does have, it uses some subtraction. So for instance, we know that we don't do that for 4. We take a 1 from 5. So they wouldn't use this. They would use this is more common. Now they're okay with this. I've learned through a little bit of research that they were okay with this in a lot of ways and would read that. But for the most part, we use the proper Roman form, which would not use 4 of a symbol, but would take 1 from the symbol in order to represent 4. Okay, same with like 90. A C represents 100 and an X represents 10. So we would do this for 90, representing 10 less than 90. Okay, so sometimes you see that for a 90 instead of doing this. Okay. Which, like I said, sometimes they would do this, but for the most part, they're going to subtract and do that subtraction. And the X is, the way you know that it's being subtracted is if a number, if a digit that represents a quantity that is less than the quantity before it, then we know that there is a subtraction there. Okay? And so first, this is 4, but this is 6. Because the 1 is after the 5. Okay, so you can find a lot of information about the Roman on the web or anywhere, and so I'll leave you to research that one a little bit more instead of going further into it. Okay, and then let's move to Babylonian. Babylonian is a place value system. It's another place value, and it is base 60, okay? And very much like the Mayan, it only has 3 symbols. The Mayan has the 5 and the 1 and the placeholder. Babylonian has a 1 and a 10 and a placeholder. So they use this symbol to represent 1, and they use this symbol to represent 10. They write their digits horizontally like we do, okay, with the highest at the front going down to the smaller place values, and then their placeholder is kind of a double line. Most of the time you'll see these kind of filled in. And just to save time, I'm not going to fill them in as I do this on the board. But just know that when you see it in print, that these symbols will be filled in. A lot of times also you'll see little tails on the ones, the same thing still representing a 1 with or without the tail. Okay, is base 60, the powers of 60. Of course, we have our 1s place, we have our 60, and then 60 times 60 is 3,600. Okay, you probably don't need much more than that, but you can multiply that by 60 again, of course, 60 cubed to find the next place value. And so if I wanted to, I'm going to write a Babylonian number and we will convert it to base 10. So they kind of join their symbols like this. space to represent a new place value, and we're starting with this symbol. They usually have their ones on this side and then their 10. So now that I'm over here in the ones, I know that this is a new place value. Okay, and I'll have these. All right, so this is our first place value, and then this is our smallest one. So these are our ones and these are our 60s. So in this case, we have two 60s, okay? Because this is our one and we have two of them. And then we have a 10 plus 5, so 15 ones. Okay, so 120 plus 15, this is 135. Okay, so that's just a little bit about the Babylonian system. Let's do it in reverse. Let's represent one of our base 10 numerals in a Babylonian. Okay, get kind of big. Let's do 532. All right. So this is smaller than the 3600, but it's bigger than 60. So we know that 3600, we're not going to use that place value. We're just going to have two place values in this numeral, which seems crazy since it's 3 digits in ours. 2 for a base 60. Bigger base, okay, less place values needed to represent a numeral. Okay, kind of interesting to think about that. So I'm going to take 60 and put it into 532, see how many 60s I'm going to need for this place value. It goes in 8 times, and 60 times 8 is 480. Okay. Do the subtraction, we get 52, and so this is how many ones we have, because the next place value, the next lowest would be the ones place. So 8 60s and 52 ones. That's the downfall to some of the larger ones, is I'm going to have to write 52 of this. So put our 8. Of course is less than 10, so I have to use my ones and write 8 of them in our 60s place, and then leave a space and start our 52. So I'm going to have 5 of these 10, trying to distinguish these from these, make sure, careful there. Okay, so 60s, ones, and then we need 2 more. So this is our 50. And then I'll just stack them like this for 2. Okay, so that's moving to Babylonian. All right, now our last ancient numeral system is the Greeks. And once again, you'll just need to look at the link to show you some Greek symbols and what each Greek alphabet letter represents in a numeral. So I'm going to use some of them. It's an additive system. Okay, which means that, and Greeks are really not fussy about things, so they really wrote these in any order, but we'll keep it a little bit easier and write it in greatest to least, just like our numeration system, just because that's what we're used to. That's kind of what the Egyptians did. And so we'll start with some Greek letters. And you look at the chart to see what each letter represents. So this is a Greek phi, and it represents 500. This is a Greek mu. It represents 40. And this is a Greek alpha, and it represents 1. So this is 541. And then if we wanted to go backwards, say I wanted to write 285, I would just look up in the Greek alphabet what would be 200, what would be 80, what would be 5. So that's what they used. They did their 1 through 10, and then 20, 30, 40, and then their hundreds with their Greek alphabet to represent those numerals. And then they started using symbols over them and stuff to represent thousands and 10,000s and stuff. Okay, you can read a little bit more into that with some just online resources as to how to represent some of the larger numbers, but just getting the hang of it, using letters and what they represent. So if I look it up, a sigma is what represents 200, and we write that like this. Pi is 80. I'm kind of familiar with pi. And epsilon represents 5. And there you have it. All right, so there are all of our ancient systems. I think it's really interesting to look at some different numeration systems. This allows us some flexibility and really some appreciation of our own numeration system, and kind of some explanation as to why so many, why we adopted it. We weren't the first as U.S., it's Hindu-Arabic, and then why it also replaced the Roman numerals in that world as well. So interesting to kind of look back and see what people kind of used to represent quantities in ancient times. Thank you so much.